So we looked at and found the force on Q1 right here due to Q2 and Q3. But we're going to do something that at first is going to seem like, why would we do this? And what we want to do is imagine that Q1 is gone. So I've just erased Q1 from the setup. And we want to say what would happen, what does it look like right in that situation where Q1 is actually out of the picture. So with Q1 gone, what we can do is say at this point, which X marks the spot, or sometimes we mark it with point P, at that spot, when you sit there, you can imagine a field associated with both of these charges, that these charges would set up. If I came in with a positive charge, I would feel something called a field that would want to pull me towards this. I think of this sort of an invisible field. I'm a big Star Wars fan. If you haven't seen Star Wars, your education is lacking, but you need to watch A New Hope, which was the very first Star Wars movie that came out, but now in the Star Wars series, it's considered number 4. Anyway, A New Hope. And there is this tractor beam that has this force field that you don't see it, but when you get in, it pulls you in, okay? So it's a field that acts. So the idea is that if I suddenly appear there, then I would feel this force. So it's something that's there, but I only notice it when I actually show up. So this is what we call an electric field. And it shows up in that direction and in this direction, in the direction we had before, this 37 degrees. So this is the electric field, this is the electric field due to charge 2. The pink one is charge 2, the green is charge 3. And it works basically the same way we had before. Instead of the force, now we would say the electric field at 2 is just, well, we just disappeared Q1. So it's K Q2 over R squared in the I hat direction. Similarly, the magnitude of the electric field due to 3 is just K Q3 over R squared. That's the magnitude. And then it has components, right? E3 is equal to this magnitude times cosine of 37 degrees in the minus I hat direction plus E3 times the sine of 37 degrees in the minus J hat direction. So basically it's the same thing we did. We just got rid of our Q1. But when our Millennium Falcon suddenly shows up there, or a charge shows up there, the force on a charge at that point, is going to be the charge, so Q1, times whatever the electric field is at that point, the total electric field. And the total electric field would be E3 plus E2. So E3 plus E2, here would be my E total, right, like that. Okay, so this is basically the same thing we did before, but what an electric field does is say, what would happen if I put a positive charge there? So the electric field is, E field, tells us how strong a force, magnitude, and in what direction if there's a positive charge, if a positive charge sits there. And so you can imagine at X marks the spot, there's no charge there, we can find the electric field. Now this is not the electric field right here or the electric field right here. In fact, at the location of the point charges electric fields, because that would be an R of 0, which goes to infinity. So that's sort of problematic. But the electric field right here points down. If this is a big charge compared to this one, points down like this. If we're asking what is the electric field closer over here, it might point more in the x direction and less sort of down, because we would have we would see more of an effect from this bottom charge right there. And so what we try to do is try to make an electric field map for a situation so that we can say, hey, if I put a charge there, if I put a test charge in this location, what the test charge does is it shows us, it points in the direction of the electric field. That's the job of a test charge, is to say, hey, what direction does this electric field point? And then how strong is it going to be? So here it would be a little weaker, really over here that would be a really strong field, and right here would be a strong field, here would be a nice strong field, right? Where the force, if we're sitting right here, we would have a positive charge where this blue X marks the spot from Q3 would be down, and then similarly from Q2 would also be down if Q2 is a weaker charge. So altogether we would have an electric field that was down right there. So it just depends on where we enter this field as to how strong our force would be and also in what direction it would point. So we're going to spend a lot of time trying to map out electric fields, but remember, from whatever the total electric field is, once we know the charge, how strong is our Millennium Falcon that's jumping into here, that tells us then our force. Okay? Because our electric field for point charge is K, Q times that point charge over R squared. R is our distance to wherever we're interested in. Our distance to X marks the spot.